That is fine. In Form 1, we looked at those types of mirrors called plane mirrors. Now, we were looking at how light is reflected on those plane mirrors, and we looked at where they are applied. Things like kaleidoscope, the periscope, and what have you. Now, in Form 2, we introduce light 2, which is another topic on light, but in this particular case, still on reflection. We shall look at reflection at curved mirrors. Now, have you ever seen a curved mirror anywhere? If you have a car, just walk out, look at that car. There are two things which look like ears on the sides of the car. They are called side mirrors. If you look at the side mirror, or even on a motorbike, leave alone a car, there is something written on that side mirror of the motorbike. Can you go and read? By the end of this lesson, tell me what you read on that side mirror. So those side mirrors are not like plane mirrors. If you look at yourself in that side mirror of a car or of a motorbike, you will tend to be a small person. Your head will be smaller than it is as compared to a plane mirror. Plane mirror, you see an object same size as the image. The image and the object are same size and only laterally inverted. That means if you raise your right hand, what happens? The image raises the left hand. That was called lateral inversion. And if you move closer to the mirror, the image also moves closer. So you seem to be moving close to each other. That was in plane mirrors. Now in curved mirrors, something else will happen. As you look at the side mirror, you will see you will have a wider field of view behind you. That's why they are used as what? As driving mirrors. We shall also look at some of you have visited dentists. They have a special type of mirror, which we shall see by the end of this. You tell me which mirror is that. There are those that are also used by barbers. We call them shaving mirrors. So these ones just to ensure that they see every part of your head as compared to a plane mirror. So those mirrors together, we are calling them what? Curved mirrors. Why are we calling them curved mirrors? Where did they come from? So these curved mirrors, we just cut a part of either a cylinder or a cone or anything curved. So we cut part of it. Like if I have this as a cylinder, you see it is already curved. It can be clear as this glass. This is glass and it's very clear. So I can decide to make this glass to be a mirror. It is curved. So I can, what can you guess what we can do? One, we just put an opaque something this other side. Then the opposite side becomes what? A mirror. Or it can be another type of cylinder. Then you paint on one side with a shiny paint on one side. So then it becomes what? A mirror. Or you can apply some silver on one side so that the side is shiny. Then that will form a mirror. So if the shiny part is on this outside, we shall have a different mirror as compared to when the shiny surface is inside. So we are saying if I have this is my curved surface. Let this represent a curved, some part of a cylinder like this. Then I decide that I want to paint on one side. So if I put a shiny paint on this other side, on my left side, this side, that means this side will be shiny. So this is now our reflecting surface. So this becomes our reflecting surface. So this other side is opaque like that. So as light comes from this other side, if light strikes that mirror, it will be reflected either that way or this way. So this becomes our reflecting surface. Now the other way, if I still have the same piece of glass or piece of material, then now I make it shiny on the inside. So this other side becomes opaque. That means the reflecting surface is inside. So as light comes from this direction, it is reflected in this direction like that. So can you imagine of areas where we use these types of mirrors? So we are saying the curved surfaces can be obtained in two ways. Either by polishing them or by painting so that they become so shiny for us to use them as reflecting surfaces. It can be even a metal. When you polish a metal, if this was a metal, then I polish this side, it becomes shiny and it becomes a reflecting surface. That way you can use it as a mirror. So some of you, it's not a must for you to go to buy a mirror. You can just apply some shiny polish. There, you see in high school, Form 1, when their shoes are still new, I used to hear guys say, "Wow, unaweza jionea kwa kiatu," because it was shiny, it was well polished. Na hata vumbi ikishika kidogo anarudi dom kupanguza. By break time anataka kitembea, you can see yourself through the shoe because it has been well polished and very shiny. That is what we are saying. So you can either polish that surface or paint with a shiny paint, not a dull one, a shiny one, so that it can reflect. I've seen some people that, Kenyans have very bad manners sometimes. Someone, if a car is still new, it is usually the body is usually shiny. You see some people walking around and using it as a mirror. You see them close to the vehicle like this because the body is shiny. It was well painted with a shiny paint. That's how we can use it as a mirror. That is true. You can confirm today. Now these curved mirrors, so we have said they can either be formed by applying silvery paint or by polishing. That's two ways of making curved mirrors. Now there are two main types of curved mirrors. Now what are the next question we want to ask ourselves is, how many types of curved mirrors do we have? So you write types of curved mirrors. Types of curved mirrors. Now we have already explained that they are formed or obtained from hollow shapes or spheres or cones or cylinders, all those. So there are two main types of curved mirrors, and the name depends on the reflecting surface. Where is the reflecting surface? So we have two cases. One, like this one here, where the reflecting surface is bulging outwards. We are saying it's bulging outwards. And this one, the reflecting surface is converging. So like you can see, it seems to be curving inside. The names are different. For this one, where the reflecting surface bulges outwards, it's called a convex mirror. Convex. So convex mirror, that's the first type. And we have said in a convex mirror, the reflecting surface bulges outwards. It bulges outwards. Then the opposite of this is called concave. Concave mirror. So we have convex mirrors and concave mirrors. Now for concave mirrors, the reflecting surface is inside. It curves inside. You can see from, if this is my A and this is my B, you can see for A, the reflecting surface is bulging outwards. Just call your sibling and mwambie akuletee kijiko. So kijiko kiko na two sides. If this is the kijiko, there is the side ya kuweka kwa kidheri hivi ukikula, na kuna hii side ingine. So those two, there is one side that is bulging outwards. So if you turn the kijiko like this and look at yourself, then try turn it like this and look at yourself, you will not see the same thing. You will realize there is a difference. So the outer side of your kijiko is an example of what? A convex mirror. Is an example of a convex mirror because it's bulging outwards. Then the inner side of the kijiko, where you scoop something with, is called a concave mirror. Is an example of a concave mirror. So because it is converging, it's converging. Converging means it seems to be like all the rays, as we shall see later, after hitting the reflecting surface, they all go to the same place. They converge like that. And an example of this we shall see later. And also in Form 4, you will now look at lens. So if you have a glass and you don't paint on both sides, it becomes a lens. But if you paint on one side, so that is a reflecting surface, now it is called a mirror. So we are saying there are two two main types of mirrors. One is called convex, another one is called concave. And the difference is we look at the reflecting surface. If the reflecting surface is inwards, if the surface is curving inwards, that is called a concave mirror. And if the reflecting surface is curving outwards, that is called a convex mirror. Now, in short, most of these mirrors, we draw them like this. We will have just a line like this. If this is my line, we will always shade the side that is, if we shade this side, it means the reflecting surface is this other side. This is the reflecting surface. So this is, the shaded part is opaque. So light will be coming from this other side. Then the other one, if I have the same piece of glass, then, or piece of metal, then now I shade this side. If I shade this side, then this other part becomes the reflecting surface. So part A here, this represents a convex mirror, and this one represents a concave mirror. So these are the two main types of mirrors. However, there is a special mirror. There's a special curved mirror, the third one, which is called a parabolic mirror. A parabolic. Now, you've seen, if you have a torch at night, then you met some police officers with their own torch. Wakimulika na wewe umulike. Yours looks like a panya among lions, because their reflectors are powerful. Their reflectors, their type of torch they use looks like this. So it is so much curved like that. That's called a parabolic reflector. Then you shade this other side. So we shall also have a parabolic concave and a parabolic convex, depending on the reflecting surface. Now look at this other one and this. This one is much curved as compared to this. So what happens if there is a bulb here and a bulb produces light like this in all this direction, this reflector produces a very powerful beam like this. That's why they are used in searchlights and in car headlamps. So if you look at the car headlamp, if you look at the reflector there, it is not wide like this too. It is narrow like this one, so that it produces, there's just a small bulb, but it produces a very powerful beam of light. Unaweza ona mbali, once you take a corner, you can see so many people ahead there because of the type of reflector. This is called a parabolic mirrors. So there are two main, and this one is the third one, called a parabolic mirror. And parabolic simply means it's a special type of mirror where the reflecting surface is narrow, is not as wide as a concave and convex like that. Now that leads us to our next thing, which is a definition of terms associated with curved mirrors. Definition of terms. What are some of the terms? You know, as physics people, you need to use specific terms so that we understand each other. Just like lawyers, you will hear them say my learned friend, subsection 2, part B. So the terms associated with curved mirrors. Now to help us understand these terms, I want us to look at the diagram on your screen. You can take a minute and draw on definition of terms. So in order to understand some of those terms, we can use those two diagrams. So the first one is for the convex mirror, and the one on the right is for the concave, then convex. So in order to understand, we can look at those two mirrors. You can see something written C. There is another one F. Then there is a P. You can see some small f, some small r there, with some distances, some arrows showing. Then there is somewhere written XY. Then there is this other one, in part B, the convex mirror. You can see F and C are behind the mirror. Then you can see some rays of light. How do you know this array of light? The path taken by a light is called a ray of light and is indicated by a straight line with an arrow to show the direction. So those two, we will use them to define some specific terms. So you can copy this or take a screenshot or take a photo of your screen on TV there. Then we'll be referring to them every time we are defining. Like when I say C, you need to go back to your diagram and see what was this C for a concave mirror and for a convex mirror. So those two figures there can be used to define some terms. Now these terms, the first one, the key terms, the first one is called depending on your teacher of nursery, you can say it is either aperture or aperture, the way you want to pronounce. That depends on you. So me, I'll say aperture. So what is the aperture? And looking at those diagrams, we are saying that is the diameter of the reflecting area, the diameter. Like, what do we mean by diameter? If I'm talking about the first type of mirror, this one, the diameter of this mirror, and then in short will be the distance from X to Y. So that is the aperture of the mirror, the distance from X to Y. That's what we are calling the aperture. So if you look at your diagram that I said you draw and look at it as we define, so the aperture is simply the distance X, Y. Which we are saying is the what? The diameter of the light reflecting area. The area that is reflecting light is called the aperture. That diameter, that distance from X down to Y is what we are calling what? The aperture. Then you can see something at the center of this mirror somewhere here. You can see some P there. So this P stands for pole. So number 2, the second term is pole, the pole of the mirror, the pole of the mirror. So in this context, because pole may mean so many things, kama ile miti ya stima, we are not talking about miti ya stima. We are talking about the center of the what? Of the mirror. The center of the mirror, whether it is concave or convex, that center is called the pole of the mirror. Then you can see somewhere along this line, there is some C and there is some capital F. Now I want to start with the concave mirror, C. C is usually the center of the, you see, we have said a curved mirror is just part of some surface, like if it was a cylinder or if it was a sphere. If it was a sphere is, we usually draw it as a part of a circle. It's a circular like this, the two-dimension view. So this was a sphere and the center was here. Then this was the diameter. Then someone decided, I don't need the whole of this sphere. Akakuja, akavunja hapa na akavunja hapa, alafu akatoa hii like this. So you can see this, then akasema, now let me paint one side, then this became a mirror like that. So this C here was the center of the original sphere of which this mirror is part. That's what we are calling C. And C stands for center of, also this one, it depends on the way you want to pronounce it. Center of, how will you pronounce this? Center of curvature. Center of curvature, C. So this is just the center of the sphere from which this mirror was cut, because I have shown you this was a whole sphere. Alafu mtu akakata like a ball. If you take a ball, alafu kate kuanzia huku juu mpaka chini, pap, it will look like this. It will look like a bowl, kama bakuli. Then that center there, if you bring back the other piece, it forms a whole ball. So you cannot, that ball is an example of a sphere. So after cutting the ball into two, this other part, the center remains the same, whether you are using this part or this part. So the center of curvature, C, we usually say, is the center of the sphere of which this mirror is part. This mirror is part of a certain sphere. So the center of that sphere is what we are calling the center of curvature. Then closely related to that is the principal axis. The principal axis. That's another term. The principal axis. The principal axis. Not the spelling. Principal. Ile ya principal wa shule. Si principal a rule. Principal axis. And we are saying principal axis is actually a straight line, a line drawn through the pole of the mirror and the center of curvature. So naweza sema principal axis in this case is the line CP or CFP. So the line drawn through the center of curvature to the pole of the mirror. That line, that straight line, we are calling it the principal axis. The principal axis. It's a very important line. When we will be doing ray diagrams, the beginning of all ray diagrams, first of all, you draw the principal axis. Even when we shall be doing graphical analysis and graphical representation, we will always start by drawing the principal axis. Just like in graphs, you must draw the Cartesian plane, the x and y. So we will start always with the principal axis, then we draw. What did we say is this? The aperture of the, so we have the pole, we have our C, then we will draw the aperture. So this vertical line here represents the aperture. Then this CP is the principal axis. So when we'll be drawing ray diagrams, we will start drawing a mirror like this. We will not draw a whole mirror, so we need to just use some lines to represent our mirrors. Then another one is called, you can see some F somewhere, some F. So this F is from the word focus, and because it is a main point of focus, we will also call it principal focus. Principal focus. Some other guys will say it is called the focal point. Focal point. Focal point. It is a point. That's why we are calling it a focal point. What does this point represent? So the principal focus, if you look at our two diagrams that we looked at before, when I said you will be referring to those diagrams every time, if you look at those two diagrams for the convex and concave, you notice something. One, for the concave mirror, F is in front, and for the convex mirror, F is at the back. If you look at the diagrams that we drew before. So what does that tell us? That for light and its properties, anytime you will see a line like this with an arrow, this represents a real ray. But if you see a dotted line like this with an arrow, this represents an imaginary, what we call a virtual ray. Virtual ray. Virtual simply means not real. It's not real there. Like right now, I'm doing a virtual lesson because you guys who are listening to me and watching from wherever we can't meet right now. I don't know even where you are. So we are doing this lesson virtually. This is not a real class. It is a virtual class. So virtual means not real. So a virtual ray is an imaginary ray, a ray that is not there. So if you look at the two diagrams for the concave mirror, remember when we shade this side, it means the opposite side is the reflecting surface. Then you see some line here with some C here and some F here. Then we have shown you something. If I draw a ray which is parallel to the principal axis, always someone proved that it will always be reflected through F like that. Whether it is even from this other side, so long as it is parallel to the principal axis, it will always go through F like that. So for a concave mirror, we will define our principal focus as the point at which all rays parallel to the principal axis do what? Converge. After reflection, they'll all meet here. And we shall see, for this reason, that's why we use a concave reflector in a projector lamp. You know a projector? If you look at a projector, there is a small lamp there, and that reflector is called concave because all rays that are parallel to the principal axis will meet here, and that is how we form the image, a clear image on a projector. And we shall see more other options, like even the car headlamps, we use this type of reflectors. So we are saying for a concave mirror, it is where the rays actually they converge, they meet here after reflection. As they move like this, they hit the reflecting surface, they are reflected through the focal point. So that point is what we are saying, the principal focus. Now there is a small difference when you look at the other one. If you look at this other one, which we are calling the convex mirror, this one. So if this is my principal axis, you will see F here. There is F this other side and C. So that means the center of curvature and the principal focus for a concave mirror is real. It's a real one. It exists. It's in front of the mirror, so it is real. But for a convex mirror, the focal point or the principal focus and the center of curvature is not real. It's imaginary. That's why it is behind the mirror. So in this case, for a convex mirror, if a ray strikes the surface like that, what will happen? It is reflected, and someone looking at it will think that it's coming from F. It appears to come from F. Even if I have another ray here, so long as it's parallel to the principal axis, it will appear as if it's coming from F like that. So when we are defining the principal focus, we must be sure which type of mirror are we referring to. So for a concave mirror, what have we said? That it is the point where all rays parallel to the principal axis converge. They meet there after reflection. What about for a convex mirror? For a convex mirror, that is the point at which all rays parallel to the principal axis appear to diverge from. It looks like they are all coming from here. All rays that are parallel to the principal axis. A ray strikes the mirror like that. It is reflected in a way. If you are from this side, you will think that it is coming from here, from the focal point. So I'm using these dotted lines this other side because the principal focus and the center of curvature for a convex mirror is not real, is virtual. So therefore, we are saying that for a convex mirror, the rays appear to diverge from here. But for a convex mirror, the rays converge at F after reflection on the curved surface. Is that clear? I hope I'm very clear on that. Because when we have seen this, when we asked students define the principal focus and they define it generally, then you will miss a point. So you have to be specific. Are you talking about a convex mirror or are you talking about a concave mirror in that particular case? So get that clearly. For the concave mirror, maybe you can add as another point that for the concave mirror, F is real because it is in front of the mirror. So it is real. F is real for a concave mirror, but F is virtual for a convex mirror because it is not real. The rays appear. The moment you use the word appear to diverge from here, then we say F is not real, but it is virtual. It is a virtual point on the convex mirror, like that. Then we have the, after knowing those terms, we need to have three more. The one called the focal plane. So there's another term there called focal plane. Then there's another one called radius of curvature. So we have the next term, number 6. The next term is called focal plane. Focal plane. And what does a plane mean? A plane is simply the one that is perpendicular to the principal axis, is what we are calling the focal plane. The plane perpendicular to the principal axis is the focal plane. So when we'll be drawing ray diagrams, we shall represent the principal axis with the horizontal line and a vertical line to represent the focal plane. So this plane, this other side, the whole of this thing, which is perpendicular to the principal axis, is what we are calling the focal plane. So all rays will be approaching the focal plane, obeying the laws of reflection. Like a ray can come from here to this point, it can strike the surface like that, it can strike the surface like this. All these rays approach the focal plane. So the focal plane is just a plane perpendicular to the principal axis, as simple as that, a plane perpendicular. Now in the simplest way, we are saying you just draw a line which is perpendicular to the principal axis, and that's what we are calling a focal plane. Then there is something called the radius of curvature R. That is number 7. Small r, or radius of curvature. We use small r. So, like the distance, what is usually r? The distance from the center of a circle to the circumference. So that means initially we had a whole sphere like this. So we had a sphere. Remember that? So if this is a sphere, there is that as the diameter, then this as the center. So this center here in terms of mirrors, we are calling it C. Then this point here, we are calling it the pole. So someone cut this mirror here, nakakata hapa, like that. Then we painted this side, something like that, for us to have formed what? A mirror. Then we removed this part, like that. So we removed this. So we are saying, does this change the radius of whatever is remaining? No. So this distance from here, from the center here to the pole, is what we are calling the radius of curvature. So it's simply called the radius of the sphere of which the mirror is part. The radius of that sphere where we got our mirror is called the radius of curvature. It is the distance from the center of curvature to the pole of the mirror. You can also define it like that. Distance from the center to the pole, or simply the radius of the sphere of which this mirror is part. Then the last distance is there was some letter here, F. From F to P. From F to P. What did we say is F? F was called the principal focus, or the focal point. So the principal focus, the distance from that principal focus to the pole of the mirror, we call it the focal length of the mirror. The focal length, small f. So our last term is focal length, which is f. Now looking at this keenly, you realize something, that if this is the radius, then the focal length is always halfway from the principal, from the pole of the mirror to the center of curvature. F is always halfway. What does that tell you? Though we shall prove this later, you realize the distance, mathematically speaking, CF is equal to FP. So if CF is equals to FP, then it means CF is some small f and FP is also some small f. So what is the distance PC? PC will be PF plus FC, which is F plus F, and you get 2F. And this distance PC is what we are calling small r. So we will prove later that r, the radius of curvature, is twice the focal length of the mirror. In most of the cases, no one will mention r for you. When you are going even to buy those mirrors and even lens, as we shall see later in Form 4, we will be referring to the focal length. So the power of a mirror depends on the focal length. The power of a lens depends on the focal length, not the radius. Because once we know the focal length, the radius is twice the focal length. So you will, when people are buying lenses or mirrors, there are those, some mechanics will tell you you need this type of lens, focal length 20 or 10, because their power is different. A mirror whose focal length is short is different from that whose focal length is too long. We'll see the difference between those two, and that's how some cars, their side mirrors are very powerful. You see some clear images than others because of the focal length of the side mirror used. So sometimes I've seen someone replace a side mirror with a plain mirror. That is very dangerous. You take a plain mirror, ni kio ya kawaida, unakata vizuri, unapelekea mechanic, akaeka na super glue. That's very dangerous because you will only see what is directly behind you. You can't see the other mirror will provide a wider field of view. You will see so many vehicles. You will see the vehicle behind and the other side. But if you use a plain mirror, it shows only within 90 degrees. It cannot show you something behind at angles. So it's very dangerous. Now we want to look at another subtopic as we move towards winding up. Reflection of light. Reflection of light. Reflection of light by curved mirrors. Reflection of light by curved mirrors. I know in Form 1 you did reflection of light. You even did something called loss of reflection. If I take you back there for a minute, we were saying this, if this is a plane mirror, so a plane mirror we represent it by a straight line like that, then we indicate the normal. So let's say the normal is here. Normal simply means the line perpendicular to the plane. This is the plane, so this is the normal. Then you are saying if at this point of incidence, if a ray strikes like this, and this angle here is 20, that's called angle of incidence, the angle between the incident ray and the normal. Then it will be reflected this other side like that, and this angle will also be 20. So the first law of reflection was the angle of incidence. This angle is called I. The angle between the incident ray, this is called incident ray. Incident ray is simply the ray striking a plane. Ile ray inagonga hapo, that ray is called incident ray. Ile ray inatoka ikienda huko, hiyo inaitwa reflected ray. This is called a reflected ray. Then the point where the incident ray hits the mirror, that point is called point of incidence. Point of incidence, where the incident occurred, point of incidence. So the angle between the incident ray and the normal was called the angle of incidence I. And the angle between the reflected ray and the normal was called the angle of reflection R. The first law of reflection was the angle of incidence is equal to the angle of reflection. That was law number 1. Then the second law was at the point of incidence, the incident ray, the normal, and the reflected ray, all of them are on one side. So they fall in the same plane. They are in the same plane. You can see all of them are out. There are two planes here. There is this upper plane and the lower plane. So the incident ray, the reflected ray, and the normal, where are they? All of them are above. So they fall in the same plane. Now when we come to reflection at curved surfaces or curved mirrors, we shall, all this, because it is still light, it will still obey the laws of reflection. So light striking, a ray of light striking a mirror at an angle, it will be reflected through the same angle from the surface of the curved surface, from the surface of the curved mirror. Now to look at the effect of reflection of a concave and a convex mirror, we will need what we call a ray box. So we will use a ray box. What does a ray box what is a ray box? It is a box just producing rays of light. You know, we want to do experiments, so we must direct them. This is when you go to university, you will do some experiment under optics in a dark room. So it's totally dark. You only want to depend on the rays coming from a certain specific box called a ray box. So we are using a ray box because we can manipulate the way we want the rays to come. So for a convex mirror, we will have two. We will have a concave mirror here, which looks like that. Concave mirror. This one is a concave. Then we have the other one, which is convex mirror, bulging outwards like that. So this one, remember, it is always like that. There is your F somewhere. There is some C somewhere. There is some F here and a C like that. Then we make these rays to be, parallel to the principal axis. So as they strike the mirror, what happens? For the concave mirror, we have already said they'll all converge at F. They'll all converge at F. That's a very important point. They'll converge through F. Then for a convex mirror, they will appear to diverge from F. They will appear to diverge from F for a convex mirror. Now, if something interesting, so we make the rays first of all to be parallel to F like this. All rays parallel to F like that, like this, like this. What will happen? So those are our incident rays. So they are striking the mirror. After reflection, this ray goes through F like that. This other ray also goes through F like that. This one goes through F like that. This one also goes through F. So all the rays that are parallel to the principal axis, it is observed that they all pass through the principal focus after reflection. What about convex mirror? For a convex mirror, the rays that are parallel and close to the principal axis, they'll be reflected such that they appear to diverge from the principal axis. So this one, it goes like that. It appears to be coming from there. Remember, the dotted lines means they are not real. These rays are not here. They are just reflected. So they appear as if they are coming from there. This one, the same thing like that. This one, the same thing like this. So for a concave mirror, the rays converge at F after reflection. Then for a convex mirror, the rays appear to diverge from F after reflection. Now something interesting is, if we make these rays now, if we make the rays to go through F and see what happens, so that now you, from the ray box, you direct the rays, all rays to go through F. So it is coming from somewhere. Now in this case, I can use, so the blue one means they're coming from the ray box through F like this. These are now through F. All of them are through F. The blue ones are through F. This one also through F. It's a ray directed to F. Directed to F. What have we done? It's like the way you move from, if you move from the sitting room to the kitchen, you must use the same route when you are coming back. So here we moved from somewhere. We were parallel to the principal axis and we appear to come from F. Now we want to see what happens if the rays are directed to F. You will see, as after reflection, they are reflected parallel to the principal axis. So they follow the same path like this. They follow the same path. The red ones, they are following the same path. I hope you are following. One, we made the rays parallel to the principal axis. Then what happened? For a concave mirror, they were reflected such that they all converge through F. Then for a convex mirror, we have said they appear as if they are diverging from F. Now we are making the rays direct through F. So for a concave mirror, after they pass through F, then they'll all be reflected such that they appear to they become parallel to the principal axis. Maybe we can look at the diagram on slide 8, page 8 there. You will see clearly, so that I differentiate the two. The next slide, you will see for the convex mirror, those that are appearing to be directed to F, still the next one, you will see that they also emerge as parallel to the principal axis. What does that tell you? What has happened is the light, the rays are just following the same path, but the path has been reversed. The path has been reversed because they were coming like this. It's like they were parallel like this, then they went through F like that. Now what have we done? We want now them to go through F. Now they appear parallel like that. So what has happened? This route and this route are same, but one is in the opposite direction. So here we are moving from A to B, then to C. In this case, our C here is our F. They are passing through F. Now in this case, we have directed a ray to go through F, then to hit the surface B, then it goes to A. So what has happened? In case 1, the ray came from A to B, then to F. Case 2, the ray came through F, then to B, then to A. So these two are the same. What is the difference? The paths have been reversed. This has been reversed. The paths have been reversed. So this tells us a special, this is a special observation or a special characteristic of light, that when an ray of light goes in this direction, if a ray can move from A to B, if this is A to B, and this is a ray of light, if you reverse it, it will still follow the same path. So it can still come from B to A along the same path. That is called the principle of reversibility of light. Principle of reversibility of light. The principle of reversibility of light, which says that the path followed by a ray of light can be reversed. So in one case it is moving in this direction, the other case it is moving back in the same, along the same path but in opposite direction. That observation is called the principle of reversibility of light. Principle of reversibility of light. Then we have already said that reflection at curved mirrors obeys the laws of reflection. Now, there are some practicals that you will do when schools resume. You will do some practicals to determine the center of curvature and to determine the focal length. You will do that when schools resume. So I want to skip those practicals and look at the ray diagrams. The last subtopic for today. Remember our three objectives? Our three objectives, ray diagrams, was the last one. We take some few minutes on it. Ray diagrams. We just mentioned a few things, then in part 2 of this lesson, we will wind up and see some past paper questions. So ray diagrams, what are ray diagrams? So we cannot draw everything like the way the image is and the object, the way they appear in the mirror. We only use what? Ray diagrams. So we use these ray diagrams to help us explain the formation of images and their characteristics or properties. So we will only use ray diagrams. Now, someone was wondering, will we be drawing all those curved mirrors, or what have you? No. So there are very key things that we need to know. In the ray diagrams, we have the object, then we have the mirror. You need to know, how do you represent the mirror? How do you represent the object? And especially the type of mirror. So the object is represented by a straight line. The object is represented by a straight line with an arrow. What do you think the arrow is for? The arrow shows the tip or the head. If it is someone, the arrow will be meaning the head of the person. So if you see a line like this with an arrow, this means this is the object. That is an object. So this is the head of that object. This is the tail. So, or this is the tip of the. So if this is someone in kichwa, in miguu, that is someone in a mirror. We cannot draw the whole person and say we are drawing a ray diagram. That's why it's called a ray diagram. Then how do we show that this is which type of mirror? So for a mirror, we shall also use a vertical line to show the mirror, so like this. But to show the type of mirror, we put a small curve on top of this vertical line. Like for the concave mirror, we shall put a curve like this, then shade this side. That means this is a what? A concave mirror. Instead of drawing the whole curved mirror, we shall use a straight line, which is a vertical line, and on top of that line, we indicate the type of mirror by a small curve and shading appropriately. So a convex mirror will be like this. Then we put a small curve like that and shade this side. So this one represents a convex mirror. So I saw some students somewhere in a mock exam. They had said complete the ray diagram below. Then they had drawn something like this. Let me remember it very well. Like that, then like this. Then they had put something here like this. Then they had put some F and some C. Complete the ray diagram. Then state the characteristics of the image formed. Do you know what the student asked? There's a problem with question 3. The type of mirror is not indicated. Is this a convex mirror or a concave mirror? then I'm saying like the question is okay. But the student is arguing, no, there's a problem. What was the problem with that student? The student had forgotten ray diagrams and how they are represented. So this one, you look at the top of the car of this vertical line. That tells you the type of mirror. This was a convex mirror. Then the next question was, where is the object? Where is the object? What are we reflecting? I can't see anything here. Then one of the students, you know, they like joking, said, use your pen. So you put your pen here like this and say that's the object. That does not make sense. So the object in this case was this vertical line with an arrow. So this is the tip of the object, this is the tail, like that. So from here you can draw your ray diagrams as we want to see. So the mirror line is always represented by what? A vertical line. Then this horizontal line, a horizontal line like this with the mirror at 90 degrees. This horizontal line represents the principal axis, like that. So you need to know all those things. Which one is the object? Which one is the mirror? Which one is the type of mirror? Where do you place the object and what have you? Then the image. To locate the image, you use any of these three rays. This one never forget. If you forget this, you will never draw even a single ray diagram. There are three special rays that we use to locate to draw the image actually. So one, the special rays. There are only three special rays that we use for ray diagrams. Ray number one is array parallel to the principal axis. So in this case, we are talking about, let's say this is a concave mirror. This is for a concave mirror. So this is my principal axis. So there is an F here and a C here. So array parallel to the principal axis to a concave mirror will always be reflected through F. That is for a concave mirror. For a convex mirror, what will happen? For a convex mirror, we have agreed before that is F, that is C, and convex, you draw a curve at the top like that. So array parallel to the principal axis for a convex mirror will be reflected such that it appears to come from F like this, like that. So that is the ray number one, special ray number one. So array parallel to the principal axis. How is it reflected? For a concave mirror, through F. For a convex mirror, appears to diverge from F. That is it. A very important ray. You need to know this one. Number two, another special type of ray is ray through the center of the mirror. Array through C. We can just say that. Array through C. Why is this a special ray? Array through C will always look like this. This is for a concave mirror. So I put like that. Then there is F and there is C. So array through C will look like this. We can even decide that the ray this time is going like this through C. So this is my C. So this ray is always reflected along the same path because it hits the mirror at normal. That means at 90 degrees. So it's reflected along the same path. Array through C. This is for a concave mirror. For a convex mirror, the same thing. If this is a convex mirror, like that, and you have your F and C, so that ray will appear like this. Array through C will be reflected along the same path. You need to get that clearly. You can write what I'm saying because you will forget. Array through C is reflected along the same path. Array parallel to the principal axis is reflected through F for a concave mirror, appearing from F for a convex mirror. Then the last ray is array through F. The last ray, number 3, is array through F. So for all diagrams, we shall only use 2 of these rays. The first one, I'll tell you which one are always a must. Array through F we already said from the principle of reversibility of light, what will happen? A ray through F, if this is my F, like this is my F here, this is my C, a ray through F will be produced parallel to the principal axis, like that, for a concave mirror. Then for a convex mirror, the same thing, our F is somewhere here. So a ray appearing to go through F like that, this one should be dotted, will be produced parallel to the principal axis, like that. That's very important. So we have some C somewhere there, like that. So these three rays, when we'll be doing ray diagrams, location of images using those ray diagrams, we shall be using any two of these rays. The first one, which is a must for you to use to make your work easier, is this one. So you can circle this one. You say this one is a must. When you are drawing ray diagram, the first ray to draw is this one. Then these two, it depends on what you want, the position of the object. The position of the object may demand you draw a ray through C or you draw a ray through F. So you will always use any two rays. Once you have drawn two rays, the intersection of the reflected rays forms the tip of the image, I'll just show you one example there. Then another important thing is that all real objects and real rays are represented by continuous lines, while all virtual images and virtual rays are represented by dotted lines. So if you see something like we had an image here, if the rays, let's say they met somewhere here, that's the tip. So you must draw a dotted line like that and put the tip. So for convex mirrors, all rays and images that appear behind the mirror, you must use dotted lines because they are virtual, they are not real. For a concave mirror, it will only be virtual if it appears to be behind the mirror. Otherwise, most of them are formed in front of the mirror. So if I just show you one example of if you are given an object position, then you are told draw a ray diagram. We shall see how that happens. So if this is, let's say this is a concave mirror, for this case, this is a concave mirror, like that. Then you have your F here and you have your C. Then let's say we have an object that is an object between C and F, something like this. This one will be too big. Let me even use an object between F and P. Just an example, an object between F and P. We want to see where the image is formed. So what we shall do, we shall draw two rays. The first ray, we have said we draw a ray parallel to the principal axis. This one, which is through F like that. Then another ray, we can draw a ray through F. We can draw a ray through F like this. A ray through F is reflected parallel to the principal axis like that. So this one does not help us, so we can't use that one. So we draw a ray through C like this. A ray through C like that. A ray through C. So you see, these rays are not meeting anywhere. That means the image is formed far, far, far away, what we call at infinity. So before I wind up, I want to take few questions from our viewers from wherever they are. I'll read just few. I'm Moses Wamatu from Managua. I'm happy with the lesson. That is good. Does the parabolic mirror being tested in KCSE? That's a good question. The parabolic mirror will only be tested like a 1-mark question or a 2-mark question, where you just tell us where they are used. So we have said in searchlights and in car headlamps, because they produce a parallel beam. What's a plane mirror? It's not plane, it is plane. We say plane, but we write like this. What's a plane mirror? A plane mirror is a flat surface, the flat mirror, the one that's just flat, like the mirror you use at home right now. That's plane means flat. The opposite of plane is curved. So a plane mirror is just a mirror made from a flat surface. Brenda Silvans from Migori. What is the advantage and disadvantage of using convex mirrors, driving mirrors? A good question. So convex mirrors, though we have not mentioned that, you realize advantage one, they have a wider field of view. So you'll see a bigger space as compared to a plane mirror. The disadvantage, which I wanted you to go and read on the motorbike side mirror, is when you are using the side mirror as a convex mirror, it always shows smaller images. So if you are a wrong judge in terms of driving, you will judge that the vehicle behind you is too far away when it's just close. So you need to make the right judgment. So the objects in the mirror are smaller than they are. So the distances are not real. You will see utakuwa na reverse na unaona hii ukuta bado iko mbali, alafu utasikia ushagonga, because the image in the mirror is smaller than it actually is. So the distance is not real. That's a disadvantage. Brenda, I hope you got that. Brian from Kitale, a dentist has a choice of 3 small mirrors, convex, concave, and a plain one, to examine the back of your teeth. State which one should he use to give the best view. In dentistry, we want a magnified object, so we shall use a concave mirror. We shall look at that in applications, because a dentist wants to see your teeth clearly. So we need a mirror that magnifies. We have already mentioned that a convex mirror shows small objects. So if you want to see a magnified image, like a barber and a dentist, they'll use a concave mirror. I hope you got that clearly, Brian from Kitale. And then lastly, why is it that when you look at yourself at the spoon, your image appears to be upside down? A very good question. Why is it upside down? We shall look at the ray, using the ray diagrams. We shall see the image formation and characteristics in our next lesson, so that you understand well. Like in describing the characteristics of the image using the ray diagram, we will have to see where is the image formed, so that is the position. How is the size of the image compared to the object, and is it real or virtual? Then is it upright or upside down? All those, that is part of our, if you look at the last slide, if our producer shows you the location of images using ray diagrams, we shall look at those things. So just keep calm. The next lesson. Good morning, I'm Yvonne from Kikuyu. Please give me a simple explanation for focal plane and focal length in an exam situation. No one will ask you a focal plane, they'll ask you focal length. Focal length, what did we say, is the distance from the principal focus to the pole of the mirror. That's what we are calling focal length. Focal plane is the plane perpendicular to the principal axis. So that should be the last question. Just to make sure you got it right, if this is the principal axis, then I have a perpendicular line. The whole of this thing, this one, is what we are calling the focal plane. Focal plane, because our focus is on this plane. But the principal, the focal length is the distance from the principal focus to the pole of the mirror. This distance, a small f, this one. This one, we will use it very many times, so you will get used to it. We will have some calculations of getting the focal length and what have you. Maybe the last question is rectilinear propagation of light. Christine from Siaya. Rectilinear propagation is just a term to scare you. It simply means the property of light to travel in a straight line. Rectilinear, linear means line. So it's the property of light to travel in a straight line. That's what we call rectilinear propagation. Propagation means movement. So light is moving or is traveling in a straight line. That's what we call rectilinear propagation. So that one is explain why frying pans are fitted with wooden handles. That one is not on this topic, but it is wooden. Something wooden is a bad conductor. The guy from Kakamega, that's Sheila from Kakamega. Frying pans are fitted with, what will happen if they were metallic actually? You cook. Will you be comfortable to handle them while hot? So that one is a question of another day. I hope I've answered most of the questions. Thank you for watching. I want to remind you, convince your parents and ensure that you have this book here. Those questions you are asking, some of them are answered in this book. If I check very well, like rectilinear propagation of light, without lying, let me tell you even which page. Rectilinear propagation of light. That is reflection, that is page 15. If you go to page 15 of this book, chapter 7, reflection at plane surfaces, definition, transparent, translucent material, then rays and beams, rectilinear propagation of light, the property of light to travel in a straight line. Page 15 of this book. Get your copy. See you next time. I am Teacher Donald. Have a good day.
Approximately 1 to 800 infants are born with Down syndrome in Kenya. Down syndrome is a condition whereby an infant is born with an extra chromosome.
Down syndrome is a genetic disorder which is basically caused by abnormal cell division during just immediately after fertilization.
You can follow this conversation on our social media platforms at KUTV Focus on Health and also on Facebook, and Health Focus on Instagram.
Sasa ni bora zaidi, mwanzo mpya, mambo mapya. Msimu mwingine wa Boresha Kilimo unakuletea teknolojia ibuka, kilimo mseto, uongezaji thamani. Teknolojia dijitali ya mauzo inawezesha ufikiaji wa masoko. Soko moko yako, mahangaiko yako ya kufikia masoko yamefika kikomo, manake tunao Mkulima Young.
What Mkulima Young does is it connects farmers with the market.
Hii ni Boresha Kilimo kwa ushirikiano na Mkulima Young. Atafutaye hachoki na kichoka kesha pata. Kwa makala maalum ya kilimo, ungana nasi kila Jumamosi saa 6:30 kwenye kipindi ukipendacho Boresha Kilimo.
Lola is an app that gives you a chance to watch videos, listen to audios, and read articles wherever you are for free. Motivational stories, dramas, campus life, technology, lifestyle, adventure, sports, academics, jobs, entertainment, and more. Download Lola now on Play Store. All you need, you got Lola.
This program is rated GE. Content carried in here is suitable for general family viewing.
Good morning, students and viewers at home. Welcome to Elimu Live, the show where you get content in maths, chemistry, science subjects, and other art subjects. With you today is Mr. Alan Nyonga, a teacher from St. Joseph nearby. My subject combinations are maths and chemistry. Today, I'll be taking you through chemistry. And in chemistry, we have paper 1, paper 2, and paper 3. In paper 2, the most common question you'll always get is touching on periodic table. And that's the topic I want us to touch on today. The structure of an atom and the periodic table. There are some definitions which you need to understand before we dwell more into the topic. And the first definition is an element. You need to know how to define an element, and we say an element is a pure substance that cannot be split by any chemical means. So the word is pure. It's a pure substance which cannot be split by any chemical means. The other definition is an atom, and an atom, we have said, an atom now is the smallest particle of an element that takes part in a chemical reaction. It's the smallest particle of an element that takes part in a chemical reaction. So from that definition, from those two definitions, we can see that an element is a pure substance. Then this element has small particles, which we refer to them as an atom. And thus it touches on the topic, the structure of an atom. Let me take you back to our notes. We have to see the subtopic, the subatoms, which make up an atom. We'll see that an atom has other subatomic particles, which we refer to as protons, neutrons, and electrons. So we can say we have protons, neutrons, and electrons. Those are the three subatomic particles we have. I'll draw a structure to show what they appear in your screen, the three subatomic particles, and there I'll show you the structure of an atom, which is usually a circle, and we have a smaller particle inside there, which we refer to as the nucleus. So students at home, you need to understand which particles are found inside the nucleus and which particles are found on the energy level. Back to the diagram, you can see the small circle in between there. That's what we refer to as the nucleus. And the particles found there are, we have your protons and you have your neutrons. So two particles found inside the nucleus are protons and neutrons. Protons and neutrons. Then the other bigger circle, or the other space which is in between after the circle, we refer to it, the space which I've shaded, we refer to it as the energy level. So that space is referred to as the energy level, and the small circle is referred to as the nucleus. So protons and neutrons are found inside the nucleus. Electrons are found on the energy level. Another thing, students, you need to understand, these particles have charges. Protons have a positive charge, electrons have a negative charge, neutrons have no charge. They also have masses. Protons have mass, neutrons have mass, electrons don't have mass. Those are the three subatomic particles. Next, we can move to define other terms which will assist you to those two terms. Also, they are usually tested and help you to know the relationship between protons, electrons, and neutrons. So the first definition is atomic number. Each element has an atomic number. The first element whose atomic number is 1, that element is referred to as hydrogen. So that shows you that each element has an atomic number. Oxygen, the atomic number is 6. Calcium, the atomic number is 20. And magnesium, the atomic number is 12. So what is this atomic which we are referring to, 12, 6, or 8? Atomic number is the number of protons in the nucleus of an atom. It's the number of protons in the nucleus of an atom. So if you are told that calcium, the atomic number is 20, what does it mean? It means that it has 20 protons in its nucleus. It means it has 20 protons inside its nucleus. The other definition we look at is mass number. What is mass number? Mass number is the sum of protons and neutrons in the nucleus of an atom. Is the sum of protons and neutrons in the nucleus of an atom. So if the mass number is 40, it means if I take 40 neutrons and 40 electrons, if I take 40 neutrons and 40 if I take 20 protons and 20 neutrons, then I'll get the mass number. Let me give you a good example. You can be having sodium, Na. Then it has been written down here 11, then up is 23. Up is 23. So when you have such kind of let me just rub it so I can show it clearly. So let me rub it so we can show it clearly. Sorry for that mishappening. Let me just clarify before we handle the situation. We have said that the mass number is the sum of protons and neutrons in the nucleus of an atom, while the atomic number is the sum of protons, yes, and the sum of protons and the neutrons in the nucleus of an atom. So when you have your diagram and you want to show, if you want to see the relationship between mass number and atomic number, you'll have an example where first let me rub so I can show the symbol of sodium. So if you have your symbol, the element is Na. If you have the element to be Na, then you put the lower number. That's your Na. Then down here, you put 11. Up here, you put 23. What does 11 represent? 11 represents the atomic number. 11 represents the atomic number, while 23 represents mass number. So if you can be asked how many protons are in that atom, so the symbol is Na, not N. N is for nitrogen. So 11 is representing the atomic number, 23 is representing the mass number. So you can show P, how many protons? P will be 11. Then how many neutrons? How many neutrons? Neutrons, we have said mass number is the sum of protons and neutrons. So to get the number of neutrons, you have to do 23 minus 11, which should give you 12. Then what about electrons? You can also be asked to calculate the number of electrons, or E. In short, we refer to as E. So how many electrons does it have? For a neutral atom, the number of protons are always equal to the number of electrons. For a neutral atom, we'll check when it's not neutral. If it's not neutral, the protons and electrons are not equal. So if you had said that the number of protons are 11, also the number of electrons should be 11, or that should give you 11. And that's how we use atomic number and mass number to know how many protons an atom has, how many electrons an atom has, and how many neutrons it has. 12 plus 11 gives you 23. So next I'll take you to some questions, and those questions also dwell more on how to calculate the number of protons, or how to link the protons and neutrons in an atom. So the table, when it comes to your screen clearly, first you are supposed to use the information in the table to answer the questions that follows. And the table, we have elements, atomic number, mass number. So the elements are B, C, D, E, and F. The atomic number of B is 18, the mass number is 40. So to analyze that scenario, it means that B has 18 it has 18 protons, since that the mass, the atomic number, and also it has 18 electrons, because we have said for an atom, the number of protons and electrons are always equal. Let's move to the next letter, which is letter C. You see how it looks, letter C. So letter C, we have 5 atomic number and mass number 10. To interpret that, it means it has 5 protons, it has 5 electrons, but to get neutrons, you have to do mass number minus atomic number. With that analyzation, you can also do atom for your own for element D, E, and F. Let's move to the first question. The first question is asking, which 2 letters represent the same element, and give a reason. Which 2 letters represent the same element, and give a reason. If we can go back to our definition, we didn't look at the definition of an isotope. An isotope. And we need to know what is an isotope. An isotope are atoms of the same element with the same atomic number but different mass number. Isotopes are atoms of the same element with the same atomic number but different mass number. So that can help you to answer the first question, which is asking which 2 elements which 2 letters represent the same element. What is an isotope? Atoms of the same element with the same atomic number but different mass number. From the table, you can see that it's element C and D, which have the same atomic number, but their mass number is different. So the reason, you're supposed also to give a reason. So the reason is they have, the answer is B and C, and the reason they have same atomic number but different mass number. So I hope students at home, that question has helped you to know how to define an isotope and how to identify an isotope given the atomic number and given the mass number. Let me take you to question B. We also look at it. Question B, you're supposed to give the number of neutrons in an element D. Give the number of neutrons in an atom of element D. Back to mass number and atomic number. What did we say mass number? Mass number equals to neutrons plus protons. That's how you get mass number. So if you go to element D, what was the mass number of element D atom? You can check from the table. Element D, the mass number is 7. Mass number is 7. So if the mass number is 7, you can say 7 equals to N plus P. We can know P. P is protons. And if you remember well, the definition of an atomic number is the number of protons in the nucleus of an atom. So if the atomic number is 3, also the protons are 3. So also the protons are 3. And now when you're at home, you can say N plus 3. And 7, if 7 equals to N plus 3, automatically what's your answer? If 7 equals to N plus 3, what's your answer? That will be 7 minus 3 and you get 4. So that question helps you to know definition of an isotope and also how to know the relation between mass number and atomic number, and also how protons and neutrons, when you add, when you add protons and neutrons, you get mass number, and electrons are usually equal to protons if it's an atom. Back to another question. So let's move to another question. We check. Still is on table. Chemistry is more about analysis, and usually one way of analyzing data is when it's in tabular form. So that question also still involves a table. We have a table where we have substances X, Y, and Z. Here, instead of being given the number of mass number and atomic number, you have been given how many electrons it has, how many protons it has, and how many neutrons it has. So, one thing you need to know about what I've said earlier at home, students, we have said an atom, protons and electrons are equal. an atom, protons and electrons are equal. Why, if protons and electrons are not equal, now the substance is referred to as an ion. We refer to the substance as an ion, A-I-O-N. And ions can be either positive, can either be positive. If you have an ion, can either. Good morning back, students and viewers back at home. Sorry for the small hiccup which we had. Just a reminder on what we were touching. We were touching on the structure of an atom, and we defined the atom, what's an atomic number. We have defined what's a mass number. Let me just add you another definition. An ion, which I didn't which I didn't touch on. An ion is an atom which has either gained or lost electrons. And when it gains electrons, the electrons become more than protons, so it becomes negatively charged. When it loses an electrons, the electrons become less than protons. So if the protons are more, then it is positively charged. And a positively charged ion is referred to as cation, while a negative charged ion is referred to as an ion. With those definitions, we can go back and handle our question, which we are looking at. Yeah, we have our table there on air, and we had three substances. That's substance X, Y, and Z. And the X, it has 10 electrons, 10 protons, and 10 neutrons. So at home you can know what the mass number of the atom and also what the atomic number. The atomic number will be 10 because it has 10 protons, and the mass number will be 20 because mass number is protons plus neutrons. So the first question is asking which letter represents an ion? Which letter represents an ion? I've indicated that for an ion, the protons and electrons are not usually equal. It's either one is less than the other one or more than the other one. So if you look at our substances at home, we have X, electrons and protons are equal, 10, 10. So that's an atom, it's not an ion. If you look at Y, the electrons are 10 while protons are 8. It means the electrons are now more than protons. So that's one answer which you can state to be your, that's what you can say is an ion. So in short, you can just say your ion is letter Y or substance Y. You put Y as your answer. The next question is asking, let's move to the next question. We see what it's asking. Which of the substances are isotopes? Give a reason. Which of the substances are isotopes? Give a reason. If I take you back to the table, we check. We know that isotopes are atoms with the same atomic number but different mass number. And atomic number, if the atomic number are the same, it means also protons are the same. So if you check your table, which substances have the same number of protons? Y and Z. Hence, your answer, you'll say the substances which are isotopes are Y and Z. Y and Z. Reason, they have same number of protons but different number of neutrons. Reason, they have same number of protons. Protons are the same, but electrons are different. Electrons are, sorry, not electrons, but neutrons. The neutrons are different. Let me take you to another question, which still on atomic structure and periodic table. We have electron arrangement of ion X, 3+, and ion Y, 2-. The reason they have been classified as ions, you can see very well they have charges. There's one which is positively charged, and there's one which is negatively charged. When you say X3+, it means the protons are more by 3 compared to the electrons. So it means it had lost 3 electrons. That's why it is 3+. When you go to Y2-, what Y2- means, it has 2 more electrons than protons. So it has gained 2 electrons. So the electron arrangement of X, you have been told is, the electron arrangement of X, you have been told is 2:8. while the electron arrangement of Y is 2 is to 8 is to 8. So if X is 2 is to 8, if X is 2 is to 8, then it means before it was 2 is to 8 and it had 3 electrons, it has lost 3 electrons. So initially it had 3 electrons. So it means X, the electron arrangement before it gained was 2 is to 8 is to 3. 2 is to 8 is to 3. So that's the electron arrangement of X. 3 plus means it had gained. So if it's 2 is to 8, I've added the other one. Now let's move to Y. What about Y? Y, for Y, you can say it was 3 minus 2 minus. 2 minus means it has gained 2 electrons. So you subtract the 2 electrons which it had gained, so it becomes 2 is to 6. Not 2 is to 8 is to 6, but 2 is to 6. So you say 2 is to 6. And so you have answered let's go to the first question, which is asking write the electron arrangement. Write the electron arrangement of element X and Y. So in the previous page, which are done to write the electron arrangement of X is 2 is to 8 is to 3, while for Y is 2 is to 6. So your answer, you just say X equals to 2 is to 8 is to 3, while for Y you say is 2 is to 6. That's the electron arrangement. Let's move to the next question. Is asking write the formula of the compound that will be formed between X and Y. To talk about, when you're talking about formulas, what you need to know is valency. Each element has its own valency. And in short, the definition of valency is the number of electrons an atom gains or needs or loses to become stable. So if an atom loses 3 electrons to become stable, the valency is 3. If an atom gains 2 electrons to become stable, the valency is 2. When you know the valency of each element, to get the formula of the compound, you just interchange their valencies. You interchange their valencies. So if you understand the definition of valency, which is the number of electrons an atom needs to gain or lose to become stable, it's easier to tell the valency of any element. Let me give you an example. Aluminium atomic number 13. 2 is to 8 is to 3. Because the atomic number is 13. So how many electrons will it gain or lose to become stable? Because the outermost are 3, it cannot gain 5. It's easier to lose 3. So the valency of aluminium is 3. What about oxygen number 8? Its atomic number is 2 is to 6. Its electron arrangement is 2 is to 6. So does it need to lose 6 electrons or gain 2 electrons? It only needs to gain 2 electrons. So the valency is 2. So if you want the formula of aluminium oxide now, you will interchange the valency to be Al2O3. With that explanation now, you can answer the question at home, even before I come back. So write the formula of the compound that will be found between X and Y. If you check the electron arrangement of X, it has 3 electrons in the outermost energy level. So if it has 3 electrons, it means it will lose 3 electrons. So the valency is 3. While for Y, if it has 6 electrons, the valency is 2 because it needs to gain 2 electrons. So you interchange the formula and it becomes X2Y3. And that's the formula of the compound formed between X and Y. You just interchange the valency. The valency comes from the outermost electron. I hope that is clear. Let me take you to another question which still involves structure of an atom. The question there, it says, still, I've emphasized science is more about analysis. So most of the questions you'll find they'll be involving tables. So the table below, you can read the question from home. Then let me take you directly to the table. There is the table. Now you can see the different ways how questions on atomic structure are usually set. Here now they don't give you the number of protons or electrons or neutrons. What they have given you is electron arrangement, atomic radius, and ionic radius. Atomic radius is the radius of the atom. while ionic radius is the radius of the ion. So if you can analyze your element K, the electron arrangement is 2:8:2. Electron arrangement can give you a lot of information. When you look at electron arrangement, the number of outermost electrons tells you the group to which the element belongs to. The number of energy levels it has tells you the period to which the element belongs to. And also it also helps you to know if the element is a metal or a non-metal. Any element with less than 4 electrons in the outermost energy shell is classified as a metal, while any element with more than 4 electrons in the outermost shell is classified as a non-metal. So with that information, you can analyze the table and know which elements are metals and which elements are non-metals. Another information to help you to analyze the table is metals usually lose electrons when they form ions. So for metals, the ionic radius will be smaller than atomic radius, while non-metals, they gain electrons while forming ions. So for non-metals, when you compare its ionic radius and atomic radius, the ionic radius will be more. So when you go back to the table, you'll be able to see which one is a metal and which one is a non-metal. Like K, compare the atomic radius and ionic radius, 0.136 and 0.065. So automatically, since the ionic radius is smaller than the atomic radius, K is classified as a metal. And K is in which group? K is in group 2 because it has 2 electrons in the outermost shell. And K is in period 3 because it has 3 energy shells. So if you are drawing the structure, you'll draw the nucleus, then you draw the first energy shell, you draw the second energy shell. If you have a compass or a coin, it's better to use it so that you can form good circles, not like mine. So this is the nucleus. 2 electrons come here. The 8 electrons goes to the second energy level, and the remaining 2 go to the third energy level. Analysis is important before you go to the question, because when you analyze the table now, you're able to answer the question. Let me take you to the question number 1 regarding that table. Let me take you to the first question, and if I can read it to you before we have the first question. Which 2 elements have similar properties? Which 2 elements have similar properties? Which 2 elements have similar properties? So for elements to have similar properties, they must be in the same groups. For elements to have the same property, they have to be in the same group. And what have I said about group? Group, we have said that for elements which are in the same group, they should usually have same number of electrons in the outermost shell. So if I take you back to the table, the element which will say have the same similar properties are elements which will have same number of electrons in the outermost shell. So let's look at our table. Let's look at our table. We see the first element let's see the first table. The first table, if you're seeing it clearly, K, it has 2 electrons in the outermost shell, L has 7, M has 1, and N has 2. So which elements are in the same group? That's element K and N. Reason, they have 2 electrons in the outermost shell. So the answer which you can say in that question, you just put those elements K and N. And then in which group? That group will come to know that group is referred to as alkaline earth metal. That group is referred to as alkaline earth metal. So the answer is K and N. And the letters do not represent the actual symbols of the elements. So that K we cannot specify to say it's potassium, and N we cannot specify to say it's nitrogen. In the question, they have indicated that the letters don't represent the actual symbol of the elements. Question B, what is the most likely formula of oxide of L? So the explanation, I didn't offer the explanation. The explanation is they have same number of electrons in the outermost shell. That's the explanation why K and N have same properties. Question B, what is the most likely formula of element L? This question is related to what I was talking about. So let's look at L. Previously, when you look at L had how many electrons in the outermost shell? It had 7 electrons in the outermost shell. So with that, you can know the valency. What's the valency of L? How many electrons will it need to gain or lose to become stable? How many electrons will it need to gain or lose to become stable? So that shows it will need to gain only 1 electron. You will have only 1 electron because for it to become 8, you need 1 electron. So let me tell you the definition of valency. How many electrons does it need to gain or lose to become stable? How many electrons does it need to gain or lose to become stable? So when you go to the table, you can see that L, since L, it has 7 electrons, the valency of L will be 1. So you write valency 1. They want the formula of the oxide. For oxygen, you don't need to cram the valency. Always the valency of oxygen will be 2. So, and we have said when you want the formula, you interchange the valency. So it becomes L2O. And that's your chemical formula of the oxide of L. My emphasis still is on valency. Emphasis still comes on valencies. Writing chemical formula, really, you have to know the valencies. And we say in chemistry that chemical formula is the alphabetical letters of chemistry. So if you don't know how to write balanced chemical equation, then chemistry becomes hard. And the basic is to know the valency of an element, then interchange the valency. Let me take you back to question C. We check what we are supposed to look at regarding the table. So that question C, which element is a non-metal? Explain. You can see the way all these questions are usually linked. Which element is a non-metal? So we have said a non-metal, first, the atomic radius, the ionic radius will be bigger than atomic radius. That's one reason to classify a substance as a non-metal. Another reason to classify a substance as a non-metal, if you check the outermost electrons and you see that it needs to gain electrons to become stable rather than losing, automatically that element is a non-metal. So going back to the table, which we had earlier, because all the questions are linked to the table, you have to always go back to the table, and we can check. A non-metal first will be letter L, because the ionic radius is bigger than atomic radius. That's the reason. Ionic radius is bigger than atomic radius. So going back to your question, you say your answer, the element is element L. The element you classify it as L, and the reason, ionic radius, don't write it in short, ionic radius is greater than atomic radius. You can state ionic radius is greater than atomic radius. And that's the reason it's classified as a non-metal. Let's move to question E. Question D, rather. Explain why ionic radius of N is less than that of M. Explain why ionic radius of N is less than that of M. To the table, you can observe the ionic radius is less than atomic radius. As I was explaining how to classify a substance as a metal or a non-metal and ions, I had said earlier, metals form ions by losing electrons. So if it loses electrons, automatically it will lose the outermost energy level. And when it loses the outermost energy level, the ionic radius decreases. So that's why the ionic radius will be smaller than atomic radius, because it forms ions by losing electrons. So that's the answer which you're supposed to state. It loses electrons by gaining, sorry, not by gaining, but by losing electrons. So if you go to the question, your answer should be, it forms ion by losing electrons. It forms ions by losing electrons. That explanation, I hope it's clear at home. It forms ions by losing electrons. And you don't need to give a lot of explanation regarding the formation, how it forms ions. With the moment you just indicate it forms ions by losing electrons, that will help you, or that will earn you a mark in an exam, because the examiner will be able to know that you have analyzed the table and you have seen it's a metal, and metals usually form ions by losing electrons. Let me take you to question E. Question E is, which of the elements is the strongest reducing agent? Which of the element is the strongest reducing agent? Sorry. That's the question we have. Which of the elements is the strongest reducing agent? So the explanation I was giving for that question isn't correct. The explanation should be, which of the elements is the strongest reducing agent, and explain. So we need to know what's a reducing agent and what's an oxidizing agent. You need to know what's a reducing agent and what's an oxidizing agent. So an oxidizing agent, we need to know first oxidation. Oxidation is losing of electrons. Oxidation is losing of electrons, while reduction is gaining of electrons. So if oxidation is losing of electrons, anything which is losing electrons is called a reducing agent, because it will give electrons to the other element. And when you gain electrons, you have been reduced. So if you want to get the strongest reducing agent, you go back to your table and check which element will lose electrons. You check which element loses electrons, and when you have the element, then you are able to state the strongest. So the element which we have seen which loses electron much easily will be element M. Element M, let me get the table so we can see how element M loses electrons. And I hope that definition of what is that definition which states that what's an reducing agent is also related to ionization energy. So ionization energy is the energy required for an atom to lose the outermost electron. So an element which has less ionization energy is the strongest reducing agent. And then is the strongest reducing agent. Then we can also explain why ionic radius of L is bigger than its atomic radius. So explain why ionic radius of L is bigger than its atomic radius. That was the last question, and I said because it forms a molecule, because it forms an ion by gaining or losing of electrons. So L is bigger because it's a metal, and N has a small ionic radius because it's a non-metal. There's also some questions which you have been receiving. There's a student who is asking how many atoms of each element are present in the compound of zinc chloride. That's a question which you have got from students back at home. So for you to know how many elements an atom of zinc chloride has, you have to know the valency of zinc, and also you have to know the valency of chlorine. Then when you write the formula of zinc chloride, the formula is Zn Cl2. The formula is ZnCl2 because zinc valency is 2, chlorine valency is 1. Then when you interchange the valency, you get zinc chloride. So what does that mean? It has one atom of zinc. And chlorine, there are 2 atoms because ZnCl2. Another student has asked how many elements are in ammonium carbonate. For ammonium carbonate, also you need to know how many electrons ammonium carbonate has. So you write the formula of ammonium carbonate, and ammonium carbonate will be NH4CO3. because carbonate is CO3 and ammonium is NH4. So from there you can see that nitrogen, it has 1 atom of nitrogen, 4 atoms of hydrogen, 1 atom of carbon, and 3 atoms of oxygen. I hope those questions have been good, and I hope we meet during the next lessons as we study more about atomic structure and periodic table.
Vera Beauty and Fashion College is focused on being the leading technical and vocational training institute in the region. Our team possesses in-depth knowledge and extensive experience in the industry, offering thorough training in cosmetology, hairdressing, interior design, creative arts, training of trainers, nail technology, and fashion design, with branches in Nairobi, Thika, Meru, Eldoret, and now in Mombasa. Our courses ensure that learners are completely equipped with knowledge, competency, and employability skills. Enroll today to be a part of a center of excellence.
Welcome to Engine, an educational show for all the family. Get ready for some exciting learning and fun teaching.
How does a plane fly over the sea? How do the planets float so weightlessly? Let's go! It's technology. Let's go! Science, you and me. Let's go! We're learning every day. Let's go! Engine leads the way.
Niko Malindi katika pango ambalo linafahamika kama Mwamnyika. Pango hili, mpenzi mtazamaji, ni pango ambalo ni sehemu ya kihistoria ambayo leo utapata mengi kuhusiana na sehemu hii.
Mimi japo miliki muda mwingi uliopita, lakini kuna wengine hawajaingia hapo sababu wanaogopa kwanza. Sasa hizi ni njia tu ambazo zinazunguka kwenye hiyo pango.
This program is rated GE. Content carried in here is suitable for general family viewing.
Bongo is a Swahili word and the meaning of it is brain. You use it to find solutions. Lights out, Nina. You have to be up early for school tomorrow.
Ow!
What's wrong?
My tummy hurts. I think I overate your yummy dinner, Auntie.
Oh no. I mean, I'm glad you liked it so much, but you should have had just enough for you. We call that self-control. Sometimes you have to stop yourself from doing something even when you really want to do it, because doing it might cause harm to yourself or other people.
I see what you mean, Auntie. I guess I should have had self-control with eating your yummy food today too. My tummy wouldn't hurt if I did.
Exactly. How's your tummy feeling now?
A bit better, thanks. I think the story helped.
That's good. Now, under the sheets you go. Good night, Nina.
Good night, Auntie. I'm so excited for tomorrow. Huh? Where are the stars? What's going on with the sky today? Maybe they're just hiding today. I'm sure they'll be out tomorrow. I can't wait.
Come see my new business, Nina. I think my business hours are about to start. Just a minute. I'll be right back. Please wait here.
This is starting to look a lot like some of the places from my city. Do you need help?
I think I got it. Ta-da! I present to you Kiduchu's fruit juice stand. Thank you, thank you. I've decided to try my hand at selling fruit juice on my street. See? There's a bloom of oranges in the market right now thanks to this brand new fertilizer that makes them grow super fast. So now they are cheaper and I can earn some money to increase my savings.
Way to use your brain, Kiduchu. What a great idea.
Yes! Enough savings will make me be able to start helping buying some things around the house too.
How nice! Anything I can help with? I can still stay for a while.
Yes! Can you help me call the customers over? There goes one.
Fresh juice, fresh juice. Come and get some fresh juice. It's affordable and nice. You'll want to have it twice. Fresh juice, fresh juice. Come and get some fresh juice.
One cup, please.
Ah, that'll leave just one more cup for our friend behind you.
Mom. No, Tua, there's no more. One cup is enough for you. Let's go.
Mom.
I'm trying to teach her that sometimes we have to control ourselves so others can benefit too. We'll come back tomorrow, but one is enough for today. If you have more, the other kids won't get any. Let's go look at those colorful birds in the trees near Bibi's house instead.
Well, you did say they would want it twice.
Sometimes something can be so good that you can't control yourself and just want more, even if it might hurt you or others. I did the same thing yesterday with my aunt's food. I ate and ate until my tummy ached. She even had to tell me a story about self-control.
Oh, I don't think I've heard of that story.
Neither had I, but it's because my aunt heard it from my great-grandmother, who used the stars to tell it.
Huh?
Right? I was confused too, but my aunt offered to teach me how to use the stars to tell stories tonight.
Oh, how I'd love to learn too.
Sure, I could teach you. Phew, what a mess we've made.
Yeah, unfortunately this happens sometimes, but I try to clean up around the house at least. Look how much I made today. I'm going to make so many savings this year if business continues like this. Also, if I have self-control and avoid spending it on things that I want now but which won't help me, like sweets and stuff, I can use it to buy even bigger things that will make me happier in the future, like a new dress.
Good for you, Kiduchu. I'm going to start heading home.
Okay, see you.
What's wrong? Pendo, what's going on? Stay here. I'll go get help. There she is. I don't know what's wrong.
She's choking. Let's help her.
Pendo, are you okay?
There's a lot of plastic being thrown around that is affecting our animals.
Yes, one of my cows fell ill last week because she swallowed a plastic bag while grazing.
What's going on around us? It never used to be like this. It used to be so clean and green. Our animals could always graze freely.
I'm so thankful that Pendo is okay. I will have to feed her myself with some hay instead until we know what's going on with our land. Something is going on with the sky. It wasn't cloudy yesterday, but we couldn't see the stars. My aunt said we should have seen so many stars in the sky. She also said the sky wasn't like that when she was young. We need to find out what's going on. But who can help us?
I know who can help. Mama Ndege. She's able to fly way up in the sky. She can tell us if she has seen them lately when she flies up.
Yes, you're right. Let's go pay her a visit.
Tiny Tembo, you don't look too well.
I'm not well, Kiduchu. I haven't taken a dip or sip from the pond since yesterday morning.
Why is that?
There's something going on with the pond. It's turned green.
What? Green?
Yes. And my body got all itchy when I took a dip, and my tummy really hurt after I took a sip. Now I don't know where to go to take a dip or drink water.
Oh no! Here, I have some water. Take some.
So, something's going on with the sky and the water? That doesn't sound good.
Hey, Tiny Tembo, we're going to visit Mama Ndege to ask her why we can't see the stars at night anymore. Maybe you can come along and ask her about the pond too. She might know what's going on.
I'll take my chances. I'm still itchy. I need a bath.
Let's go.
Hey, Baraka, what are you up to?
I'm not taking any chances in the grass. I almost lost Pendo. Something is going on with the land. The grass and salt aren't pure anymore. There's plastic everywhere. Some even deeply buried in the soil.
What do you mean you almost lost Pendo?
Well, she was grazing here yesterday and she took on a plastic... What's going on with you, Tiny Tembo?
Oh, something's going on with the pond. It's become green. I can't take a dip or sip anymore.
Oh no! So what will you do now? Well, we are all going to see Mama Ndege, hoping she'll help us figure it out. Because there's something going on with the sky too. There are no stars anymore. So, there's something going on with the sky, water, and land? That's a bit worrying.
Hey, why don't you join us to visit Mama Ndege? She might know what's going on with the land too.
Yes! Sure. I don't want to have to do this every day so my Pendo can eat. It costs a lot. Let's go.
Mama Ndege! What's that ruckus? What's going on?
Mama Ndege, the pond is green. I'm itchy.
Hold on.
I can't take
Hold on. Let's exercise some self-control, shall we? Now, one at a time, What is going on?
Mamandege, the sky has no stars anymore. They've all disappeared.
Okay.
What's happened?
First, calm down. Now, stars don't disappear from the sky. They're always there. We just don't see them if something's blocking them, like clouds.
But there weren't any clouds yesterday.
Or the day before yesterday, too.
Okay, so then that means there's something else that must be blocking them.
Like what?
First of all, Tiny Timbo, you look like you need a serious bath.
I know. That's why I'm here. But I'm exercising self-control until you help Nina and Kiduchu first.
Ah, a fast learner. Take notes here, kids. Clean air is clear. So, if we had clean air in the atmosphere, we would be able to see the stars through it.
So that means there is dirty air in the atmosphere?
Must be. So think of it as a window. When a window is spotlessly clean, you can see very clearly through it. But when a window gets dirty and dusty, you can't see through it anymore. There must be some dirty or dusty particles and gases that are in the air blocking it, so we can't see through it to the stars.
But where do these dirty particles and gases come from?
Whoa!
Uncle T!
I remember my experience with these dirty particles and gases. It made me lose my voice.
Aha! I think those dirty gases come from the fuels that we use in all sorts of vehicles, like cars, buses, trucks, and motorbikes. In order for them to move, they have to burn fuel in their engines, and this produces the smoke we see.
Way to remember, Kiduchu!
That's probably it then. It's all the dirty particles and gases that we are releasing into the atmosphere that is blocking the stars from being seen.
Correct. We call that pollution.
What is pollution?
Pollution is when something is added to the environment that is harmful or poisonous to living things, Baraka.
So it's us? We are causing the stars to not be seen?
There are natural causes too, such as volcano eruptions and wildfires. But most of the air pollution is done by human activities. Yes, burning fuels to drive cars, burning woods to make charcoal or wood fire, burning trash, and having a lot of factories that use fuel. All of these release dirty particles and gases into the atmosphere.
Whoa! If we're causing it, then we need to stop it. We need clean air.
Yes, you do. Polluted air can sometimes make it so we don't see the stars, but it also has some even worse effects. It can cause diseases too, like pneumonia, respiratory and heart diseases, and even cancer.
Yo!
Well, I guess that solves it for us.
Oh, hey! Is this a party? Where was my invite?
Hey,
Hi! Hey, Kiduchu. I've heard people raving about your new business of selling fruit juice. Say, wouldn't you want a business partnership with me so I supply you with the oranges?
Of course! That's a good idea, Gedere. But you need to get on the new fertilizer. It makes the oranges grow faster and bigger. They call it the green magic.
Green magic? There was nothing magical about my green pond.
Clearly.
The pond is green, you say?
Yes! That's why I'm here. I took a dip and sip in the green pond yesterday and I got itchy all over. And now my tummy got sick.
Pollution is when something is added to the environment that is harmful or poisonous to living things.
Wait, that's probably it for you too, Tiny Tembo. It can't be a coincidence that the pond became green after the people started using the green magic fertilizer.
Ooh, you should be a detective, Nina. You see, sometimes using too much fertilizer in the soil causes it to end up in the water bodies when it rains, and the rainwater goes from the soil to the water. The fertilizers have certain nutrients that promote the growth of very small living things called algae. The algae become so many that they cover the whole water body at the top, making it clean. The algae also uses up the oxygen in the water. So the rest of the living things in the water do not get oxygen and end up dying.
That explains the dead fish I saw floating in the pond.
We have to stop this now. There are more natural fertilizers that can be used to help plants to grow well and fast. Let's start using those.
I remember that using soap and defecating in natural water bodies also poisons the water.
So that's to say it also pollutes the water?
Yes.
Water pollution.
So, can I say that plastics pollute the soil?
Indeed, that is called land pollution. And while anything like food waste and fruit peels also pollutes the land if they are thrown out all over the place instead of in designated areas, plastic waste is especially bad because plastic takes 1,000 years to be broken down.
That's what happened to Pendo. She swallowed a plastic cup that was deep in the soil, attached to the roots of the grass, and almost died.
Plastic cup, you say?
Yes!
Wow, I thought my plastic cups from my business were only making the place dirty, which I would clean up now and again. I didn't know that it can be harmful to others even 1,000 years later, especially if thrown on the ground.
So, what can we do after we tell them not to throw it on the ground? Because if we burn it, we will be releasing the dirty particles and gases into the air, which causes air pollution.
Good job pointing that out, Nina. The best way to deal with plastic is first to reduce the amount we use, then to reuse what we use, and then to recycle what's left.
I think the best way for me would be to reduce it. I can provide glasses for my customers to use, and I can wash them and reuse them after. I don't want to add to the dangers that our animals face with land and pollution.
Let's not forget that land pollution and water pollution can harm people too. When people drink or use polluted water, they can fall sick. And litter also bring flies, which can be carrying diseases.
One thing is clear here. We humans can cause air, land, and water pollution. We have seen its effects and have heard other ways it could affect us too. We need to start taking action now to reduce it.
I still want to be a part of Kiduchu's business, but I will use safer fertilizers.
And I still want to learn how to tell stories from the stars, so I will spread awareness about air pollution.
And I want Pando to graze freely and happily. So no more plastic cups for me.
I'll definitely go tell the Auto Club about all this. And I think they will help in cleaning up Kokotoa and putting bins around the neighborhoods, so people always have a place to throw their trash instead of littering.
Wow! What a wonderful solutions. We may be set in our ways, but with a little self-control, we can help each other.
Yes, because the land, the air, and the water are connected, and we too are connected to our planet and to each other.
And that is what Utu is all about.
No more pollution, no more pollution. Let's take care of our earth and be the solution. Cleaning up here and preserving what's there to protect our land, our water, our air. No more Kids, here's what to do in your Utu clubs this week. First, each one of you should share something that they have trouble having self-control with. Remember, self-control is being able to control yourself. It can be controlling how you act because of what you feel, what you want, or what you want to do, even when it's difficult.
Huwa napata shida sana kujidhibiti, kusubiri wenzangu kula vitafunwa ninavyovipenda vikiwa mbele yangu.
Mara zote natamani kuendelea kucheza game hata ikiwa muda kulala.
Nikiwa na hasira huwa naacha kucheza na wenzangu.
Labda unaweza kutulia na kupumua kwa pumzi ndefu kila unapokuwa na hasira. Itasaidia kukutuliza.
Asante. Nitajaribu kuimba nyimbo ninazozipenda huku nikisubiria watu wengine wafike kabla ya kula vitafunwa.
Ndio! Here is one of our Utu Club members practicing self-control. Seems like he is waiting for everyone to be at the table before taking a bite. That wasn't easy, but he made it. All he had to do was practice a little self-control. Now it's your turn. You can register your Utu Club via SMS or WhatsApp to connect with Ubongo Kids and receive discussion questions, activities, and more for your club. To register through SMS, text the word UTU to 20409. To register through WhatsApp, add this number to your contacts. +1234 900 1234 and then send the word Utu to our Ubongo chat. That's +1234 900 1234. Then select Utu from the menu that you receive. We can't wait to hear from you. Connecting all of us. Utu, Utu, you for me and me for you. Utu, Utu, I am because we are. Utu, Utu, I live for all of you. Utu is helping others. Utu is giving your time. Utu is caring for others. Utu is being grateful and having self-confidence. Utu is cooperating. Utu, Utu, connecting all of us. Utu, Utu, you for me and me for you. Utu, Utu, I am because we are. Utu, Utu, I live for all of you. Generosity, integrity, humility, responsibility, empathy, equality. I show Utu by being cooperative. I show Utu by maintaining peace.
I show Utu by being resilient.
I show Utu by being more patient.
I show Utu by being honest.
I show Utu by upholding equality.
I show Utu by practicing empathy.
Utu, Utu, connecting all of us. Utu, Utu, you for me and me for you. Utu, Utu, I am because
mathematics, mental acrobatics every day, all the time. Just use your mind. You use math when you measure width and length, solving problems using mental strength. Use number operations like multiplication. The number you'll find is like magic from your mind. Math is a part of everyday life. Just add, subtract, divide, and multiply. Can you solve the problem? Did you get the answer? Just use your brain and you can do it, sir. Now, don't you rush it. Just take it slow. You must be careful. Don't you know? You use math for all things in life. When you eat ugali, you count your bites. In a parade, count the steps you take. Just listen when I rap. I'm using math. Calculate the distance when you drive your car, so you will know if you've gone far. Here's something else for you to count. Can you count the teeth in my mouth? We can measure width, length, and depth, and represent with X, Y, and Z. Math is used for everything. Just do the numbers in your head. Now try to add up all the spots on my neck. How many do you see? And I even use math to get leaves off the tree.
Mathematics, 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 okay. Mathematics, how I love it. Mathematics, sing about the magic of mathematics. Mathematics, making number magic with mathematics. Mathematics, sing about the magic of mathematics. Mathematics,
Vera Beauty and Fashion College is focused on being the leading technical and vocational training institute in the region. Our team possesses in-depth knowledge and extensive experience in the industry, offering thorough training in cosmetology, hairdressing, interior design, creative arts, training of trainers, nail technology, and fashion design. With branches in Nairobi, Thika, Meru, Eldoret, and now in Mombasa, our courses ensure that learners are completely equipped with knowledge, competency, and employability skills. Enroll today to be a part of a center of excellence.
Approximately 1 to 800 infants are born with Down syndrome in Kenya. Down syndrome is a condition whereby an infant is born with an extra chromosome.
Down syndrome is a genetic disorder which is basically caused by abnormal cell division just immediately after fertilization.
You can follow this conversation on our social media platforms at KUTV Focus on Health and also on Facebook and Health Focus on Instagram.
What is this magic? I need that magic.
Somebody call 911. Anything for your girl, give me more.
And I say my sugary body, then, yeah.
Karibuni sana to the
Church O'Clock. I'm your host, Esther Becky.
And my name is DJ Tero.
We start you off with a word of prayer and get you started with a live transformational worship experience. And have our minds renewed by the word of God on the word segment.
And not forgetting new music za hii wiki, yani ndakuwa bado nawapatia pale wasanii wamekuwa kiwakali. So make sure manzo tune in because zitakuwa zina flow pia pale mixes kwa wingi, yani zitakuwa zina come through, and pia performance yani from our gospel artist hapa on Gospel Art
from 7 to
10 a.m. only on KUTV.
Technology, science,